Let's take a look at some sample problems from section 8.7 where we're solving linear systems of equations. And we're going to begin with number 9 on page 425 in our textbook. And in exercises 9 through 12, we're to match the system with the correct graph in A through D. So just number all of these. Alright, so in A we have x plus y equals 6 and x minus y equals 0. So the one equation will be x equals y, the second equation, and the other one is y equals minus x plus 6. So it would have a slope of a -1, and the y-intercept would be at 6, and that looks like B. Number 10, we have x plus y is equal to -6, x minus y is equal to 0. So again we have x is equal to y, so that would be probably answer C. Let's see if that goes with our other equation. Y equals x minus 6. So -6 is our y-intercept and -1 is our slope. So that checks out, so that's answer C. Okay, that means A and D go with 11 and 12. X plus y equals 0. That means x equals -y, or y equals -x. So that's going to slope in the other direction, and that's what happens in both A and D, so we know it's one of those two. And then x minus y equals -6. So if I subtract the x, they all have negatives, then multiply by -1, I get y equals x plus 6. So the y-intercept should be at 0, 6, and our slope should be +1, so it looks like answer A. That means answer 12 should be D. X is equal to minus y, so we know that's one of the two lines. Negative y would be -x plus 6. So if I multiply by a -1, I get y equals x minus 6. So it would be a slope of 1, and that would be answer D. Okay, number 14 we want to solve by graphing. Let's see if I can put that in here. So y-axis and our x-axis. Okay. Let's see, I think maybe let me read the equations and then I'll decide about my units. I'm going to use those major marks there because my eyesight's not that great anymore. Okay, so x plus y equals -5. So y would be minus x minus 5. Okay, I can go down one more. Okay, so let's do these by one. So 2, 4, -2, -4, 2, 4. That would be 6 up there. -2, -4, -6. So -5. And then we want to go down 1 and to the right 1. Down 1 and to the right 1. So we go up like that. Okay, I didn't do a very good job of staying on the dots. Alright, my other line is -2x plus y equals 1. So adding 2x, we get y equals 2x plus 1. So up 2 and over 1, up 2 and over 1. Alright, I want to kind of, looks like they're going to intersect right there. Okay, so this point is -2 negative 2.5. No, negative 3. Because that's negative 4. So that's negative 2, negative 3. So negative 2 plus negative 3 equals negative 5. And negative 2 times negative 2 would be 4. Plus negative 3 would equal 1. So that's correct. Okay, let's go to solving a system by elimination. And we have negative 2x plus 3y equals 1. We have negative 4x plus y equals negative 3. Okay, well, it's about 6 of one and half a dozen of the other. Let's decide to eliminate the x and multiply the top one, negative 2. So I'm just going to put it underneath so we can go ahead and add negative 6y equals negative 2. Okay, now if I add, I get negative 5y equals negative 5. Divide by negative 5. Y is negative 1. Okay, so using the first equation, negative 2x plus 3 times 1 equals 1. Negative 2x plus 3 equals 1. Subtract the 3, get a negative 2, and divide by negative 2, we get a positive 1. So I'm getting 1, 1. So negative 2 plus 3 is 1, and negative 4 plus 1 is negative 3, so it checks. Okay, let's do 22. We have x minus 4y equals 2. 4x minus 16y equals 8. Okay, I'm going to multiply the top one by negative 4 to eliminate the x's. Negative 4x plus 4y equals negative 8. Okay. Oops, that was supposed to be a 4y. Copied it wrong. 16y. Okay. We add them, we get 0 equals 0. Okay, so what does it mean when we get a true statement? It means that the two lines are exactly the same. The two lines are exactly the same. So, let's solve that top equation here for x. X equals 4y plus 2. It's the easiest one to solve for. What we do is we put the x in terms of y and the y as itself, and they put it in braces. So that's, we could also say the set of all x, y such that x minus 4y equals 2. The book does it this way, so I'm assuming that my math lab also will do it that way. Alright, 26. 2x minus 3y equals 7. Negative 4x plus 6y equals 14. Okay, let's eliminate the x again. I'll multiply by negative 2, the top one, and no, we want to multiply by 2. Sorry about that. 4x minus 6y equals 14. Add here, we get on the 0 equals 28. So this time we get a false statement. That means the two lines are parallel and they do not intersect. So our solution is the empty set. Okay, now we're going to move on to substitution. 2x minus y equals 6, and y equals 5x. Well, the y is already isolated, so I want to put 5x in place of y in first equation. So now I have an equation in one variable. 2x minus 5x is negative 3x. Divide by negative 3. X is negative 2. So y equals 5 times negative 2. Y equals negative 10. Okay, so if we look at the first equation, 2 times negative 2 is negative 4, plus 10 minus the negative 10 would be plus 10, gives us 6, and negative 10 is 5 times negative 2, so they check. Okay, in 34 we have 6x minus y equals negative 9. We have 4 plus 7x equals negative y. Okay, the easiest one to isolate is the y in the second one, so I'm going to multiply everything by negative 1. Okay, so now I want to substitute this in place of y in the first equation. So 6x minus negative 7x minus 4 equals negative 9. 6x plus 7x plus 4 equals negative 9. 13x, if we subtract 4 from both sides, equals negative 13. Divide by 13, x is negative 1. Okay, so if we plug in negative 1 in the second equation, we get 4 plus 7 times negative 1 equals negative y. 4 minus 7 equals negative y. Negative 3 equals negative y, means y is 3. And if we look, 6 times negative 1 is negative 6. Minus 3 would be negative 9. 4 minus 7 would be negative 3, and 3 in here would be a negative 3, so we're correct.